My name is Harsh, and today I'm going to talk about policy control for software supply chain. I work at SBO as a backend engineer to power our infrastructure services. I'll get right into it, and I planned this thinking that lunch would be right after, and my talk got pre-pointed, so uh, bear with me here. Um, so, if you don't know anything about software supply chain, that's fine. It's a lot like food, uh, where a bill system is like a chef, and you don't want someone you don't trust to cook your food, right? In a similar way, you don't want your bill system. Um, you don't want a bill system where you don't trust it. Like you need to trust your bill system to build the right software for you. Similarly, dependencies are a lot like ingredients. We've just been way more adventurous adding new dependencies to our software than we have been adding ingredients to our food. Like we don't go to the local market every day and find new food ingredients, do we? But with software, it's a lot different because we are constantly adding dependencies. And with that comes the risk of adding vulnerable dependencies, which is a lot like allergic food. It's very contextual in nature. It's like some people might be impacted with it, same as some software might be vulnerable to that attack vector, but some might not. But essentially, yeah. But essentially, vulnerable dependencies are which they impose a risk. Like if you keep adding dependencies without having a check, you might run into one of them and you create a risk of your software getting exploited. The next thing is incompliant dependencies, which are like illegal food. And yes, illegal food is apparently a thing. I looked up before that certain food isn't allowed in certain countries. You're not allowed to consume it. Similarly, certain dependencies that have certain licenses aren't allowed in certain organizations, just as a way business functions. Lastly, CI is a lot like a restaurant where basically you trust the restaurant to give the work to the chef, which does who cooks the food for you. Similarly, we trust the CI system to inject the right environment variables, the right secrets, hide them, and everything, and just pass on the job to the build system. But it's important that in our case we have to trust both the CI and the build system, and we cannot delegate trust like we do in food supply chain at least. So why should we care about this? Let's say that you found out log4j is vulnerable. Can you instantly find out which all of your apps are using log4j? You cannot really be reactive about it because just a grep search across your code base would just give you a direct dependency, but there could be indirect dependencies, and we don't know that depth level. Like it could depend on the language ecosystem and whatnot, and how many dependencies are allowed. So, like how many dependency versions are allowed. So it's really complicated to be in a situation where you have to reactively find that out. And also, you always need to know that when something is running in your environment, you need to know who built it and who published it. Like, why is it running in your environment in the first place? If you do not trust something that's running, if you do not know that it came from your build system, it could mean the attacker could have produced it, and he could be running crypto miners or whatever, or software that actually sends credentials to their backend. So that's a huge risk. The next thing is compliance. So a lot of software evolves. Companies choose to upgrade, like change their licenses. And if your developer, like us as developers, if we cannot stop our teammates or ourselves from upgrading when the license has changed, we run a huge risk if, let's say, a new feature we are trying to add, and we're already doing something over a network, and we add a dependency. We use a project that is using Apache, but it just recently changed to AGPL, and we just upgraded it without manually checking. We run into the risk of being incompliant and getting sued. So it's really important to get these things right. Before I go any further with more stuff, I'll just show a quick demo of what I have here today. So imagine that as a developer, I'm running, I'm developing an app. Say it's Redis in this case, and this is just think of it like GitHub Actions, but just locally. I'm using Dagger here, and let's say this is happening in the CI, right? So the first thing we do is we check for license compliance. I've marked GPL2 as prohibited license, so the CI just fails. In the next run, probably what I'll do is I'll change my dependency or whatnot, and then run the same CI again. And then this time we'll see a bunch of vulnerabilities appear based on the vulnerability levels. And then the final time, it's a happy scenario where I've figured out everything and I've fixed the vulnerabilities. In reality, what I actually did is I just kept changing policies so that it passes. But this is why it's important that the policy makers have a separate place to enforce, like separate coupling from the implementation. And the way I have done this is there's an OPA server running. I could just start it in this way. So I'll show you the policies quickly. So it's a 25-line thing. It's like a simple POC where I can just mention the policies I want prohibited. And then a review license is like, this needs some legal guidance from the counseling, like your legal team, whether this can be allowed or not. So you can have something like this, and this policy essentially accepts SBOM, and all this code just parses that SBOM and checks if those license declared are matches these prohibited licenses or not. So, I have a similar file here where I have the vulnerability levels defined, and it does something similar like what you expect, except here also I have allow list where certain times I can allow certain vulnerabilities because I know that these vulnerabilities don't exploit, like they are not an attack vector to my software at least. So certain times we can do this, and these policies essentially allow us, like with OPA, you just get a HTTP API out of the box if you just write that bit, which is nice for a couple of reasons. I'll get into that. So the next thing which happens is I have a CI flow where the HTTP API is essentially called, like we generate an SBOM from the image name. I'm using gripe and shift essentially for both the SBOM and vulnerability report. But essentially, we generate the SBOM, we check for the license, and then we generate the vulnerability report and check for, and these vulnerability check and license check are essentially calling the OPA HTTP API to check for, the policies. So, I've shown an example of enforcing it in CI level, but it's also very common to do it at CD level because not all the software we run is actually coming from us. So we deploy external software as well usually. So it's important that we have it in a CD, and this is where a lot of projects have come up, and Kubernetes API has extended like with webhooks to stop software from being deployed in these scenarios. But you could have any sort of setup where you're able to stop the process and deployment itself. And it's also important to run it as nightly scans, because over time, let's say it passed your CI and CD, but over time what happens is we find out new vulnerabilities have arisen from the existing software. So this is where nightly scans really help, because you would know that something has gone vulnerable overnight, and you will be able to catch it. So why Open Policy Agent? Like it decouples the policy management from where it's being enforced, and this is a really neat thing about it, because if developers are allowed to actually change the policies, that will be a nightmare, because they would just do what I did in the demo behind the scenes. Essentially, they would just change the policy, add all the dependencies to allow list or whatever. So it's really essential that we keep them separate, and the security team or the team that enforces the compliance are in charge of these things, and developers are forced to have that conversation with them whenever they want to, get the CI to pass and deploy a change out. Universal policy runtime is also a huge thing. So I could just run the OPA binary locally and get it to work. And it works in non-Kubernetes environments. So that's important because sometimes you might not be using Kubernetes as your orchestration system, or even if you are, you might not want that dependency on a webhook where the amount of load you might be throwing to get these policy checks could potentially hammer your Kubernetes API, and there's a risk that if that goes down, all the operations on Kubernetes API could be impacted. So depending on how you're using the Kubernetes API, that might not be what you want. Rego, yeah, that I actually used Ropa because I like the above things. Rego was something I just quickly just went through. But OPA also supports FASM. I have not tried it. It also supports CL, but it only supports it in OPA Gatekeeper. So it's not native to OPA. But there are interesting choices in any sense. So let's say we did all these things. Is it enough? Not really. So there are more things we need to look for. So one of them is SBOM scores. So SBOM is essentially the list of dependencies we have in the software, right? And they have all the licenses declared, the packages declared, and vulnerability scanners can also use this SBOM to then check up the vulnerability database if this dependency is vulnerable or not. So what people have realized is there are certain standard formats for these SBOMs, like SPDX, CycloneDX, there are certain formats. And for them to actually be compliant to the format, that's a different score. Like it doesn't take a lot for the SBOM to be format compatible. But the real challenge comes in where the SBOM being used in the context for your organization's compliance could be way different than just having that baseline format compliance. So this is where a lot of efforts upstream, like a lot of companies are realizing this, and they're making tools to actually score. Like if licenses aren't being declared by SBOMs, then the SBOM score goes low. If they are not having metadata on when the software is created, the score goes low. So I think it's really important to keep in check if the SBOMs you're using actually provide the information you want. The next thing is attestations. So basically, whenever your build system builds a software, you need to know that it was the build system who built it. And if your developer requested a build, you need to know that this developer is the one who signed this container image or this build. And attestations are a way to cryptographically prove that. Because then you know that the software running in prod is actually coming from this build system. Vex is something new where you have a standard format for having an allow list and a deny list for your vulnerabilities. So it could be coming from your third-party vendor who said that we are not impacted by this vulnerability, and they just have that document in there. Or it could be you who decides that I'm not impacted by this vulnerability, and you just have a standard format for it. So the last point is all of these things are potentially, all of these could be embedded into a single container image. So OCI 1.1 spec actually now allows for this to happen. It allows for all these metadata to be embedded into the single image. And your build system could actually just produce one single image which has all this metadata, and then your CI could just extract it out from the image and run the policy. This is really neat, and it's happening, but all the tooling needs to catch up with doing that because it's very recent that the spec actually allowed this to happen. So I have the demo repo, and chain guard blocks are really good regarding the concepts. So I would highly recommend, if you're interested in this, to go and have a read on that. That's it. Thank you.